Hello and welcome to Fixing the Future, an IEEE Spectrum podcast where we look at concrete solutions to tough problems. I'm your host, Stephen Cass, a senior editor at IEEE Spectrum. And before I start, I just want to tell you that you can get the latest coverage of some of Spectrum's most important beats, including AI, climate change, and robotics, by signing up for one of our free newsletters. Just go to spectrum.ieee.org/newsletters to subscribe. We've been covering the drone delivery company Zipline and Spectrum for several years, and I do encourage listeners to check out our great on-site reporting from Rwanda in 2019 when we visited one of Zipline's dispatch centres for delivering vital medical supplies into rural areas. But now it's 2024, and Zipline is expanding into commercial drone delivery in the United States, including into urban areas, and hitting some recent milestones. Here to talk about some of those milestones today, we have Keenan Wyrobek, Zipline's co-founder and CTO. Keenan, welcome to the show.
Great to be here. Thanks for having me.
So before we get into what's going on with the United States, can you first catch us up on how things have been going on with Rwanda and the other African countries you've been operating in?
Yeah, absolutely. So we're now operating in 8 countries, including here in the U.S. That includes a handful of countries in Africa, as well as Japan and Europe. So in Africa, it's really exciting. So the scale is really impressive, basically. As we've been operating, started 8 years ago with blood, then moved into vaccine delivery and delivering many other things in the healthcare space, as well as outside the healthcare space we can talk a little bit about, in things like animal husbandry and other things. The scale is really what's exciting. We have a single distribution center there that now regularly flies more than the equivalent of once the equator of the Earth every day. And that's just from one of a whole bunch of distribution centers. That's where we are really with that operation today.
So could you talk a little bit about those non-medical systems? Because this was very much how we'd seen blood being parachuted down from these drones and reaching those distant centers. What other things are you delivering there?
Yeah, absolutely. So started with blood, like you said, then vaccines. We've now delivered well over 15 million vaccine doses. Lots of other pharmaceutical use cases to hospitals and clinics, and more recently, patient home delivery for chronic care of things like hypertension, HIV positive patients and things like that. And then, moved into some really exciting use cases and things like animal husbandry. One that I'm personally really excited about is supporting these genetic diversity campaigns. It's one of those things very unglamorous, but really impactful. One of the main sources of protein around the world is cow's milk. And it turns out the difference between a non-genetically diverse cow and a genetically diverse cow can be 10x difference in milk production. And so one of the things we deliver is bull semen. We're very good at the cold chain involved in that, as we've mastered in vaccines and blood. And that's just one of many things we're doing in other spaces outside of healthcare directly.
Oh, fast. So, but turning now to the US, it seems like there's been 2 big developments recently. One is you're getting close to deploying Platform 2, which has some really fascinating tech that allows packages to be delivered very precisely by tether. And I do want to talk about that a little later. But first, I want to talk about a big milestone you had late last year. And this was something that goes by the very unlovely acronym of a BVLOS flight. Can you tell us what a BVLOS stands for and why that flight was such a big deal?
Yeah, beyond visual line of sight. And so that is basically, before this milestone last year, all drone deliveries, all drone operations in the US were done by people standing on the ground, looking at the sky, that line of sight. And that's how, basically we made sure that the drones were staying clear of aircraft. This is true of everybody. Now, this is important because in places like the United States, many aircraft don't and aren't required to carry a transponder, right? So transponders where they have a radio signal that they're transmitting their location that our drones can listen to and use to maintain separation. And so the holy grail of basically scalable drone operations, of course, is it's physically impossible and to have people standing around all the world staring at the sky, and is a sensing solution where you can sense those aircraft and avoid those aircraft. And this is something we've been working on for a long time and got the approval for late last year with the FAA, the first ever use of sensors to detect and avoid for maintaining safety in the U.S. airspace. Which is just really, really exciting. That's now been in operations in 2 distribution centers here, one in Utah and one in Arkansas ever since.
And so could you just tell us a little bit about how that tech works? It does seem to be quite advanced to trust a drone to recognize, oh, that dot is an actual airplane that's a Cessna that's going to be here in about 2 minutes and is a real problem. Or no, it's a hawk, which is just going about its business, and I'm not going to ever come close to it at all because it's so far away.
Yeah, this is really fun to talk about. So just to start with what we're not doing, because most people expect us to use either a radar for this or cameras for this. And basically those don't work. And the radar, you would need such a heavy radar system to see 360 degrees all the way around your drone. And this is really important because two things to kind of plan in your mind. One is we're not talking about like autonomous driving where cars are close together. Aircraft never want to be as close together as cars are on a road, right? We're talking about maintaining separation of hundreds of meters of separation. And so you need to sense it a long distance. And drones don't have right of way. So what that means is even if a plane's coming up behind the drone, you got to sense that plane and get out of the way. And so to have enough radar on your drone that you can actually see far enough to maintain that separation in every direction, you're talking about something that weighs, many times the weight of a drone, and it just, doesn't physically close. And so we started there because that's sort of where we assumed, and many people assume that's the place to start. Then looked at cameras. Cameras have lots of drawbacks, and fundamentally you can sort of, it's kind of, we've all had this, you take your phone and try to take a picture of an airplane, and you look at the picture and you can't see the airplane. It takes so many pixels of perfectly clean lenses to see an aircraft at a kilometer or two away that it really just is not practical or robust enough. And that's when we went back to the drawing board and ended up where we ended up, which is using an array of microphones to listen for aircraft, which works very well at very long distances to then maintain separation from those other aircraft.
So yeah, let's talk about Platform 2 a little bit more, because I should first explain for listeners who maybe aren't familiar with Zipline that these are not the little purely sort of helicopter-like drones. These are these fixed wing with sort of loiter capability and hovering capability. So they're not like your Mavic drones and so on. These have a capacity then for long distance flight, which is what it gives them.
Yeah, and maybe to jump into Platform 2, like maybe starting with Platform 1, what does it look like? So Platform 1 is what we've been operating around the world for years now, and this is basically looks like a small airplane, right? It's in the industry referred to as a fixed wing aircraft, and it's fixed wing because to solve the problem of going from a metro area to surrounding countryside, really two things matter: your range and long range and low cost. And a fixed wing aircraft over something that can hover has something like an 800% advantage in range and cost. And that's why we did fixed wing, because it actually works for our customers, for their needs, for that use case. Platform 2 is all about, how do you deliver to homes and in metro areas where you need an incredible amount of precision to deliver to nearly every home. And so Platform 2, our drone, we call our drone Zips. Our drone, it flies out to the delivery site. Instead of floating a package down to a customer like Platform 1 does, it hovers, Platform 2 hovers, and lowers down what we call a droid. And so the droid's on a tether. The drone stays way up high, about 100 meters up high. And the drone lowers down. And the droid itself, that lowers down, it can fly, right? So you think of it as like the tether does the heavy lifting, but the droid has fans. So if it gets hit by a gust of wind or whatnot, it can still stay very precisely on track and come in and deliver to a very small area, put the package down, and then be out of there seconds later.
So let me get this right. Platform 2 is kind of as a combo, fixed wing and rotor wing. It's like a VTOL, like
exactly.
Those guys. I'm cheating here a little bit because my colleague Evan Ackerman has a great Q&A on the Spectrum website with you, some of your team members, about the nitty gritty of how that design was evolved. But, first off, it's like a little droid thing at the end of the tether. And how much extra precision do all those like fans and stuff give you?
Oh, massive, right? We can come down and hit a target within a few centimeters of where we want to deliver, which means we can deliver, like if you have a small back porch, which is really common, right? In a lot of urban areas to have a small back porch or a small place on your roof or, something like that, we can still just deliver as long as we have a few feet of open space. And that's really powerful for being able to serve, all our customers. And this is, a lot of people think of Platform 2 as like, hey, it's a slightly better way, right, of doing maybe a DoorDash style operation, people in cars driving around. And to be clear, it's not slightly better, it's massively better, much faster, more environmentally friendly. But, we have many contracts for Platform 2 in the health space with U.S. health system partners and health systems around the world. And what's powerful about these customers in terms of their needs is they really need to serve all of their customers. And this is where a lot of our this is where our engineering effort goes, is how do you make a system that doesn't just kind of work for some folks and they can use it if they want to, but it's like, no, a health system's like, no, I want this to work for everybody in my health network. And so how do we get to that, near 100% serviceability? And that's what this droid really enables us to do. And of course, it has all these other magic benefits too. It makes some of the hardest design problems in this space much, much easier. The safety problem gets much easier by keeping the drone way up high.
Yeah, how high is Platform 2 hovering when it's doing its deliveries?
About 100 meters, so 300 plus feet, right? We're talking, about high up as a football field is long. And so it's way up there. And that, it also helps with things like noise, right? We don't want to live in a future where drones are all around us sounding like swarms of insects. We want drones to make no noise. We want them just melt into the background. And so it makes that kind of problem much easier as well. And then, of course, the droid gets other benefits where, for many products, we don't need any packaging at all. We can just deliver the product right onto a table in your porch. And, not just from a cost perspective, but again, we're all familiar with the nightmare of packaging from deliveries we get. Eliminating packaging just has to be our future. And we're really excited to advance that future.
I know from Evan's Q&A, I know that a lot of effort went into making the droid element look rather adorable. Why was that so important?
Yeah, to kind of I like to describe it as sort of a cross between three things. If you kind of picture this, like a miniature little fan boat, right? Because it has a big fan on the back, looks like a little fan boat, combined with sort of a baby seal, combined with a toaster. It sort of has that look to it. And making it adorable, there's a bunch of sort of human things that matter, right? I want this to be something that when, my grandmother, who's, not a tech savvy, gets these deliveries, it's approachable, right? It doesn't come off as sort of scary. And when you make something cute, not only does it feel approachable, but it also forces you to get the details right. So it is approachable, right? The rounded corners, right? Like, this sounds really benign, but a lot of robots, it turns out if you bump into them, they scratch you, right? And we want you to be able to bump into this droid, and it's just no big deal. And so getting the surfaces right, the surface is made sort of like a helmet foam. You can picture that, right? The kind of thing you wouldn't be afraid, to touch if it touched you. And so getting it both to be something that feels safe, but is something that actually is safe to be around, those two things just matter a lot. Because again, we're not designing this for some pilot-y kind of low volume thing. Our customers want this in phenomenal volume. And so we really want this to be something that we're all comfortable around.
Yeah, and one thing I want to pull out from that Q&A as well is, it was an interesting note because you mentioned it has 3 fans, but they're rather unobtrusive. And the original design, you had 2 big fans on the sides, which was very great for maneuverability, but you had to get rid of those and come up with a 3-fan design. And maybe you could explain why that was so.
Yeah, that's a great detail. So the original design, to picture it was like, imagine the package in the middle, and then kind of on either side of the package, 2 fans. So when you looked at it, it kind of looked like, the package had big mouse ears or something. And when you looked at it, everybody had the same reaction. You kind of took this big step back. It was like, whoa, there's this big thing, coming down into my yard. And, when you're doing this kind of user testing, we always joke, you don't need to bring users in if it's already makes you take a step back. And this is one of those things where that's just not good enough, right? To even start with that kind of refined design. But when we got the sort of profile of it, smaller. The way we think about it from a design experiment perspective is we want to deliver a large package. So basically, the droid needs to be sucked down a small additional volume around that package as possible. So we spent a lot of time figuring out, okay, how do you do that sort of physically and aesthetically in a way that also gets that amazing performance, right? Because when I say performance, what I'm talking about is we still need it to work when it's, the winds are blowing really hard outside and still can deliver precisely. And so it has to have a lot of aero performance to do that. And still deliver precisely in essentially all weather conditions.
So I guess I just want to ask you then is, what kind of weight and volume are you able to deliver with this level of precision?
Yeah. So we're designing, we'll be working our way up to 8 pounds. I say working our way up because that's part of, once you launch a product like this, there's refinement you can do over time on many layers. But 8 pounds, which was driven off, again, these health use cases. So it does basically 100% of what our health partners need to do. And it turns out it's, nearly 100% of what we want to do in meal delivery. And even in the goods sector, I've been impressed by the percentage of goods we can deliver. One of our partners we work with, we can deliver over 80% of what they have in their big box store. And it's wildly exceeded my expectations on nearly every axis there. And volume, it's big. It's bigger than a shoebox. I don't have I'm trying to think of a good reference to kind of bring it to life. But it looks like a small cooler basically inside. It can comfortably fit, a meal for four. To give you a sense, it's, of like the amount of food you can fit in there.
So, we've seen this history of Zipline in rural areas, and now we're talking about expanding operations in more urban areas, but just how urban? I don't, imagine that we'll see, the Ziplines zooming around, say, the very hemmed-in streets, say, here in Midtown Manhattan. So what level of urban are we talking about?
Yeah, so the way we talk about it internally in our design process is basically we call three-story sprawl. So this is, Manhattan is the place where, we think of New York. We're not talking about Manhattan, but most of the rest of New York, we are talking about it, right? Like the Bronx, things like that. We just have this sort of 3 stories forever. And, that's a lot of the world, out here in California, that's most of San Francisco. I think it's something like 98% of San Francisco is that. If you've ever been to places like India and stuff like that, the cities, it's just sort of this 3 stories, going for a really long way. And that's what we're really focused on. And that's also where we provide that, that incredible value, because that's also matches where you have the hardest traffic situations and things like that can make any other sort of terrestrial on-demand delivery be phenomenally late.
Well, no, I live out in Queens, so I agree there's not much skyscrapers out there, although there are quite a few trees and so on, but at the same time, there's usually some sort of sidewalk availability. So is that kind of what you're hoping to get into?
Exactly. So as long as you've got a porch with a view of the sky or an alley with a view of the sky, it can be literally just a few feet. We can get in there, make your delivery, and be on our way. And
so you've done this preliminary test with the FAA, the BV LOS test, and so on. How close do you think you are to and you're working with a lot of partners, to really seeing this become routine commercial operations?
Yeah. So at relatively limited scale, our operations here in Utah and in Arkansas that are leveraging that FAA approval for beyond visual line of sight flight operations, that's been all day, every day now since our approval last year. With Platform 2, we're really excited. That's coming later this year. We're currently in the phase of basically massive scale testing. So we now have our production hardware. And we're taking it through a massive ground testing campaign. So there's picture dozens of thermal chambers and 5 chambers and things like that, just running to really, both validate that we think have the reliability we need and flush out any issues that we might have missed so we can address that difference between what we call the theoretical reliability and the actual reliability. And that's running in parallel to a massive flight test campaign. Same idea, right? We're slowly ramping up the flight volume as we fly into heavier conditions. Really to make sure we know the limits of the system, we know its actual reliability and true scaled operations, so we can get the confidence that it's ready to operate for people.
So you've got Platform 2. What's kind of next on your technology roadmap for any possible Platform 3?
Oh, great question. I can't comment on Platform 3 at this time, but I will also say, Zipline is pouring our heart into Platform 2 right now. Getting Platform 2 ready for this. The way I like to talk about this internally is, today, right, we fly about 4 times the equator of the Earth in our operations on average. And, that's a few thousand flights per day. But the demand we have is for more like millions of flights per day, if not beyond. And so on the log scale, right, we're halfway there. 3 orders of magnitude down, three more zeros to come. And the level of testing, the level of systems engineering, the level of refinement required to do that is a lot. And there's so many systems, from weather forecasting to our onboard autonomy and our fleet management systems. And so to highlight one team, our system test team, run by this really impressive individual named Juan Abinel. This team has taken us from where we were 2 years ago, where we had shown the concept at a very prototype stage of this delivery experience, and we've done the first order math to kind of on the architecture and things like that, through the iterations in test, to actually make sure we had a drone that could actually fly in all these weather conditions with all the robustness and fault tolerance required to actually go to this global scale that Platform 2 is targeting.
Well, that's fantastic. Well, I think there's a lot more to talk about to come up in the future, and we look forward to talking with Zipline again, but for today, I'm afraid we're going to have to leave it there. But it was really great to have you on the show, Keenan. Thank you so much.
Cool. Absolutely, Stephen. It was a pleasure to speak with you.
So today in Fixing the Future, we were talking with Zipline's Keenan Wyrobek about the progress of commercial drone deliveries. For IEEE Spectrum, I'm Stephen Cass, and I hope you'll join us next time.